Hello chaps and chapettes. Now this is going to be a very quick video because honestly you get loads of questions on it, but there's not much to learn, and that's going to be about power. I'm talking about electrical power here, although honestly the stuff you learn about power in physics can actually be applied as an analogy to real life. So first of all, what we need to do is look at what power actually is. We need to understand how we define power in physics, and then we need to have a look at the equation and how that applies in electricity. Okay, and then well, basically I'll show you all the equation stuff at the back of my classroom, but for now let's actually talk about the definition of power. And physics has a very good definition for power, and it really does apply to pretty much everything in real life. Power is how much energy you can apply, or a system can use, in a certain amount of time. And the idea there is that if you can use lots and lots of energy in a short amount of time, you are, well, quite powerful. You can find out how powerful you are just by taking like a heavy weight thing. If I move this down, it's actually going to move, so I'm not going to use that. But if you take like a heavy weight of known mass and you lift it up and down, you can work out how much energy it takes to lift that thing up and down. That's mass times gravity times height, so it's fairly straightforward, right? If you want to find out how powerful you are, you take that mass, lift it up and down in about 10 seconds. You times how many times you lift it up and down to work out how much total energy you used, and therefore how much energy you used in that certain amount of time. So basically, how much work have you done in a certain amount of time? And this is where a terrible physics joke comes in, which was told to me by actually a chemistry teacher of all people, but it's stuck with me ever since my teacher training. This is how you remember the formula for power, at least in general terms of physics. My friend Power hates his job. His boss keeps making him work overtime. And that's because he's working overtime? Work overtime? I'm going to trust that you guys are laughing at the screen right now and hitting the like button because it was such a hilarious joke. But let's just talk about how this is going to work in electronics, because we don't actually have an easy way of defining energy electronics, or at least nothing that you've come across so far. But we can by using voltage and current and this idea of time. So join me in the back and I'll show you how you can work out electrical power. Let's go to the back now. My black pen has run out, so I have to go with this brown pen. I hope it looks okay. So, power equations. First of all, the catastrophically terrible joke. Power is equal to work over time. So my friend Power hates his job, he has to work overtime. Yuck. Honestly, you should remember that work done is equivalent to energy. Okay, so work means energy. So work done means energy. So we have this sort of short form of it, P equals E over T. First step on there, okay? Now, there's an equation that everyone should remember, and that's going to be this one. And the way you remember it is by saying PIV. P equals IV. Power is equal to current times by voltage, okay? What this means is that you have some potential energy, okay? And it's flowing through the circuit. So potential energy, potential difference, and it's flowing through at a certain rate of time, okay? What this means is basically some sort of energy going around in a certain amount of time, and that comes out as power. You've got the work component more or less represented by this bit, and the time component more or less represented by this bit. So that's one thing there. But say you didn't want to work out the power of a circuit, okay? Say you wanted to work out the energy of it instead. Well, that's fairly straightforward. E is equal to IV T. And all we've done there is actually rearrange this thing. We know that power is energy over time, so we can say that energy over time is equal to IV. You know, just take that bit down there, put it over here. Energy over time is equal to IV, and then just to make things nice and fit on one line, we put that T over there on that side, and you end up with IVT, I'm not sure. But there you go. I did have a way of remembering this one, where you just kind of rearrange the letters on there, and you end up with an electronic duck. And the specifics of that are, well, see, my family is Vietnamese, as in, okay, I'm not Vietnamese, I'm British, but the family I've married into is Vietnamese. And the way you say duck in Vietnamese is vit, spelled V-I-T. So convert, basically vit. So the energy in a circuit can be thought of as an electronic duck, E-vit, E-vit. Yeah? Yeah? Okay, granted, it's not as good as the power one over there, but you know, it's still an attempt to make it funny, but there you go. Right, so that is how you do the equations for power in a circuit. P equals IV, if you need energy, E equals V times IT, and this one does get combined into some exam questions. Let me know in the comment section below if you come across any exam questions which link this equation to this equation here. Tell me how you work through it. If you really struggle with it, let me know in the comment section below. Maybe I can do a video dealing with that exact question. And make sure you hit the like button on the way out, and I'll catch you in the next video, guys. See you later.